right, so let's go ahead and go over the review. So here we have 3 times the square root of 49. So remember, you can't take the square root of a negative number. So what we're going to have to do is put an I there to show that it was an imaginary number when we took the square root. So we get 3 times, square root. The square root of 49 is 7, and then we're going to put an I. Remember, you always have to put the plus or minus in front whenever you get a square root, because it could be positive 7 times positive 7 or negative 7 times negative 7. And then from there, we multiply the 3 times the 7 because it was a 3 here in the front, and 3 times 7 gives us 21. So it's going to be plus or minus 21i. Okay. Now for the next one. So on this one, go ahead and zoom in a little bit. We have 8 times the square root of 20, now negative 20. So now we can't take the square root of 20 and get a whole number. So what we're going to do is we're going to break it into 2 different factors. And remember, your factors have to be a perfect square. One of them has to be. So in this case, the square root of 4 is going to give us 2. So we're going to take that out. So it'll be times 2. The 5 is going to stay inside the square root because we can't take the square root and get a whole number. And then we have to put the I there to show that we took a square root of an imaginary number. And then we also have to put the plus minus in the front. So 8 times 2 gives us 16. So this will be positive or negative 16. And the square root of 5i. All right. For the next one, we have 2i to the 5th power. So that means we have to distribute the 5th power. So it's going to be 2 to the 5th power times I to the 5th power. Okay, 2 to the 5th power I know is 32, and I to the 5th is I times I times I times I times I. And those are a total of 5 i's. So for every 2 i's, we have to substitute that for negative 1. And this is negative 1. So that means we're left over with an I. And we have the 32 here in the front. So 32 times negative 1 times negative 1 will give us a positive 32. I'm going to write that up top. So positive 32. And then we have that I that's left over. So that would be our final answer. All right, the next one, we are going to add them. 3 plus 4i plus 5 minus 2i. So we start off by combining like terms, which are real numbers. So 3 plus 5 gives us 8. And then we are going to add our imaginary numbers. So 4i and negative 2i together is going to give us a positive 2i. And that would be our final. Now for the next one, we have 8 plus I minus negative 5 plus 2i. So here we are going to distribute the negative to each one. So we get 8 plus I minus, and a minus is going to turn into a plus 5. And then a negative times a positive is going to give us a negative 2i. And together, those two, a plus I and a negative 2i, will give us a negative I. And then when we add up the real numbers, 8 plus 5 gives us 13. That would be our final answer. So then the same thing for this one. We need to remember that we have to distribute the minus. That is the biggest mistake that I see, is we forget to distribute that minus. So it's going to be minus 4 and then plus 7i. So 2 minus 4 gives us negative 2 when we combine those two real numbers. And then the imaginary part, 8 and positive 7 together give us 15i. All right, the next one. Here I have 3i times 6. We're going to have to distribute that 3i to each term. So 3i times 6 is going to give us 18i. Minus 3 times 5 is 15, and I times I is I squared. And we need to remember, whenever we have an I squared, we need to substitute that for a negative 1. We can't leave it as I squared. That is not correct. So then from there, we're going to do 18i, and then negative 15 times negative 1 is going to give us a positive 15. Now, usually, I know we're done, but usually we don't write it like that. We always write the real number first and the imaginary second. Okay, well, that does not look like an I. All right, the next one. Here we have 7 minus 6i and 8 minus 3i. I'm going to go ahead and put this in a box. Okay, so that we have 7 and negative 6i. And we have 8 and negative 3i. So 8 times 7 gives us, I don't know, I can't think. 7 times 7 is 56. There you go. So then negative 3i times 7 is negative 21i. And then 8 times negative 6 is negative 48i. And then negative 6 times negative 3 is going to give us a positive 18. And then I times I is I squared. Okay. So we're going to go ahead and write this all out. We have 56. We have to combine our like terms, which are these two. Negative 48 and negative 21 is going to give us negative 69i. And then plus, because it's a positive 18, 18i squared. But instead of I squared, remember, whenever you see an I squared, you do have to replace it with a negative 1. Okay. That's going to end up being 56 minus 18, minus the 69i. And I put these two together because they're like terms. We're going to have to combine them. So when I combine them, 56 minus 18, let me see, 56, 46, 38, I believe. So 38 minus 69i. All right. So then this one, we have another one. I'm going to go ahead and skip number 9 just for time purposes. It's a lot like the previous problem. Let's look at 10. So when we multiply these two, we do the same thing. We put them in a box. We have x and x, negative 8i and positive 8i. So this is one of your conjugates because they're opposites of each other. One is positive 8i, the other one's negative 8i. So this is going to give us negative 8ix. This one's going to give us 8ix, which will cancel each other out. And the last one would be negative 64i squared. So when we write all of this out, we're going to get x squared minus 64. And instead of I squared, we're going to have to rewrite that as negative 1 for this I squared here. So then negative 1 times negative 64, that would give us a final answer of x squared plus 64. Okay. All right, the next one, 3 plus I over 4i. So remember, there's this rule where we cannot have an imaginary number on the denominator. So this 4i, to cancel it out, we're going to have to multiply the top and the bottom by the conjugate, which is negative 4i. What we do to the top, we have to do to the bottom. So on the bottom, 4 times negative 4 is going to give us negative 16. I times I is going to give us I squared over. And then we have the top part. So on the top part, we are going to multiply 3 plus I times negative 4i. Meaning we're going to have to distribute the negative 4 times 3 is negative 12. And then the I. And then negative 4i times I is going to give us negative 4i squared. And we need to remember the rule. Wherever we see an I squared, we do have to plug in a negative 1. So it's going to be negative 12i minus 4 times negative 1 over negative 16 times negative 1. Okay, negative 16 times negative 1 is going to give me a positive 16 on the denominator. And on the top, we're going to have negative 12i. And then negative 4 times negative 1 is going to turn into a positive 4. Now remember, the real number should be written first, and the imaginary number will be written second. So minus 12i. Now this one, we can reduce this, okay? We can divide both 4 and 12 by 4, and we can divide the 16 by 4. So we reduce the fraction. So 4 over 16 would reduce to 1/4. And then 12 over 16 would reduce to 3/4. So it would be 1 minus 3i over 4. Or you can split it, but this would be your final answer. All right, the next one. So on this one, remember, we can have an I on the bottom as an imaginary number. So what we're going to have to do is we're going to have to multiply the top and the bottom by its conjugate. So 5 minus I, and that is not a multiplication sign, sorry. And then the top, we're going to multiply times 5 minus I. So just for time purposes, if we do 5 plus I times 5 minus I on the bottom, it is going to be 25 plus I squared. Oh no, minus I squared, I'm sorry. Minus I squared, which we're going to have to reduce in a little bit. And then for the other one, I'm going to put it in a box. We have 4 and 3I and 5 and negative 5. So 5 times 4 is 20. I times 4 is negative 4I. 5 times 3I is 15I. Negative I and 3I gives us negative 2I squared. So then I'm going to go ahead and write out the numerator. It's going to be 20 minus 11I, because we combine our two like terms. Oh, it's going to be plus 11I. And then minus 2I squared. Okay. So on here, we have two places where we have I squareds. We have one here and we have one there. So we're going to have to replace those with a negative 1. So it's going to be 20 plus 11I. I'm going to go ahead and have to erase this. So I have space minus, and then 2 times negative 1. All of this is over 2 plus or minus negative 1, because we replace the minus with the negative. Now these two minuses are going to make a plus. The same with this. These two minuses are going to make a plus. So then when we go ahead and rewrite this, this is going to give us 20 plus 2 is 22 plus 11I over 2 plus 1 is 3. Okay. So unlike the other problem where we were able to reduce, because 4 and 12, we can reduce it over 16. But this one, 22 and 3, 22 does not divide into 3 and it doesn't simplify. Neither does it with 11. So it would stay exactly like that. All right, moving on. It says solve the following equation. So here we have 4x squared plus 32 equals 0. So we're going to go ahead and have to solve for x. So we're going to move over the 32 first. And we get 4x squared equals negative 32. We divide both sides by 4. This cancels, and we get x squared equals negative 16. No, not negative 16. Negative 8. Okay, then we're ready to take the square root. So then we get x equals, now we can't take the square root of 8 and get a whole number. So it's going to break down to 4 times 2. So that's going to give us x equals, the square root of 4 is 2. And then the other 2 will stay trapped inside the square root. And then we put an I for imaginary because we took the square root of a negative number. And we do have to put the plus minus in the front. The next one, 2x squared plus 18. We're going to subtract the 18 first. And we do 2x squared equals negative 18. We divide both sides by 2. These 2's cancel, and we're left with x squared equals negative 9. Then we're ready to take the square root of both sides. So we get x equals plus or minus 3, and then I, because it's imaginary, because you can't really take the square root of a negative number. Write the quadratic formula. So we're going to use negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the function that they give us, and they want us to find the zeros using the quadratic formula. So we need to know a, b, and c. So a is 1, b is negative 4, and c is positive 9. So when we plug it into the formula, it is going to be negative b. Now b is already negative, so when that happens, it's going to turn into a positive. So it's positive 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 9. And then this is all over 2 times 8, so 2 times 1. So then we're going to simplify just the part inside of the square root. Okay. This is going to be over 2, so 4 squared is 16, and then 4 times 1 times 9 is 36. So 16 minus 36 gives us negative 20. All right, so we're going to go ahead and simplify that square root. So it's going to be x equals 4 plus or minus, and then the square root of negative 4 times 5, because 4 and 5 multiply to give us 20. And we can take the square root of 4 and get a whole number. So 4 plus or minus 2 and the square root of 5i. And all of this is over 2. So our last step is to simplify. So we're going to divide each one of these by 2. So 4 divided by 2 gives us, it doesn't want to write, 2 plus or minus, and then 2 divided by 2 is 1, so that's going to become invisible. And that'll be the square root of 5i. I don't know why. Oh, there it goes. That would be our final answer. Now, sometimes they do write the I here in front. If they do, that means the exact same thing, so you'll be okay. All right, the next one, the quadratic formula to find zeros of the function. So then here, our A is 1, our B is negative 6, and our C is 13. Whoops, C is 13. So we're going to do negative B. Now, again, B is already negative, so it's going to be 6 plus or minus the square root of B squared, so negative 6 squared, minus 4 times A times C. And all of this is going to be over 2 times 1. So then we have 6 plus or minus the square root of, and then negative 6 squared minus 4 times 1 times 13 gives us negative 16. And this is over 2. So then x equals, we can take the square root of 16 and get a whole number. That's going to give us 4, and it's imaginary. Okay, well, that's going to be over 2. We're going to divide each one by 2. And then 6 divided by 2 is 3 plus or minus 2i. And that would be your final answer. All right, number 17, it says, given negative 2 is a root of the function, find the remaining root. So if we look at this equation, this is going to have a total of 3 roots. They give us negative 2 as a root. If negative 2 is a root, we know that, that x plus 2 is a factor. Now, this isn't imaginary. This is real numbers. So we can go into synthetic division first. So negative 2 is what's going to go in the little box. We write the coefficients. 132. And then we start off. We drop the 1. We need to make sure that they're in order. 3, 2, 1, and none. So we're good. So then 1, negative 2 times 1 is negative 2. Then we add. That gives us negative 8. And then we do negative 2 times negative 8 is positive 16. 50 plus 16 is going to give us 66. Then negative 2 times 66 is going to be negative 132. We add these and it gives us 0. Okay. So once you do the synthetic division, this is our equation. This is our A, this is our B, and this is our C. And we go straight into quadratic formula. So negative B. B is already negative, so it's going to be 8 plus or minus the square root of 8 squared minus 4 times A, which is 1, times C, which is 66. All of this is going to be over 2 times A, so 2 times 1. So we have 8 plus or minus the square root over 2. So I'm going to take all of that and I am going to put that in our calculator. So it's going to be 64 minus 264, which gives us negative 200. Okay, we can simplify this. What is a negative, huh? Did I write this correctly? That looks good. So this one we can break down into 2 different ones. So it'll be plus or minus the square root of negative 2 times 100. And all of this is over 2. 8 plus or minus, we can take the square root of 100, that gives us 10. We can't take the square root of 2, so we leave it in the square root, and then we put an I to show that we took the square root of a negative number. This is divided by 2. And then our last step is to distribute the 2 to each one. So 8 divided by 2 gives us 4 plus or minus 10. Oh, wait. 10 divided by 2 is 5. And the square root of 2i. That would be our two imaginary solutions, plus the other one was also the 0, which was the -2 that they gave us. So those are the 3 zeros. Okay. Remember, this counts as 2 because one is plus and one is minus. Alrighty. This one tells us given 4i is a root of the function, find the remaining root. So if 4i is a root of the function, then x minus 4i and x, oh, I just want to write x plus 4i is a factor also. Oh my gosh. Draw. Very good. So we're going to go ahead and multiply those two, and we multiply them, we get x squared plus 16. And that's what we are going to divide into the function. So x squared plus 0x plus 16, and we are going to divide it into 3x to the 4th power minus 5x cubed plus 50x squared minus 80x plus 32. Okay, so then from there, we are going to divide x squared into 3x to the 4th power. So then that means that we need a 3 and then x squared, and then we're going to multiply 3x squared times x squared is 3x to the 4th power. And we're going to multiply 3x squared times 0x, and that's going to give us 0x cubed. And then we'll multiply 3x squared times 16. And I believe 3 times 16, I think it's 48. Let me just make sure. Yeah, it's 48. And then we go ahead and subtract. So minus, minus, minus. These two cancel. -5 minus 0 is still -5. 50 minus 48 is going to give us a positive 2. X squared. And then we drop the next one, minus 80x. Okay, then we move on to the next one. So we start all over again. We have an x squared and we need a -5x to the 3rd power. So we are going to need a -5 and an x. So -5x times x squared is -5x cubed. -5x times 0 is 0x squared. -5x times -16 is going to give us -80x. So when we go and subtract, all these signs are going to change. So all this cancels. 2 minus 0 is still going to be 2x squared. These two cancel. I'm going to fill it in with the 0x. That way we don't have a space. And then we drop the positive 32. So we go one more time. We have an x squared and we need a 2x squared. That means we're missing a positive 2. And we multiply 2 times x squared is 2x squared. 2 times 0x is 0x. And then 2 times 16 is 32. So when we go and subtract, minus, 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 everything cancels. That means we did it correctly. Okay, so that means A is 3, B is -5, and C is 2. So we're going to plug that into the quadratic formula. So we're going to do x equals -b, so negative, that's going to turn to a positive 5, plus or minus the square root of -5 squared minus 4 times 3 times 2, all over 2 times 8. So 2 times 3. Move this back. All right, so then from there, we're going to get x equals 5 plus or minus the square root of, and then 25 minus 4 times 3 times 2. Let's go ahead and check that out. 25, let's see, 4 times 3 is 12, times 2, 24. That's going to give us 1. I don't know why I made that so big, over 6. And then we go ahead and take the square root of 1. The square root of 1 is 1 over 6. And then we're going to split this into two different ones. 5 plus 1 over 6 and 5 minus 1 over 6. So 5 plus 1 over 6 is going to give us 1 because 6 over 6 is 1. 5 minus 1 is 4, and 4 over 6 is going to reduce to 2/3. Okay, so those are two of our zeros. And then the other two zeros we said was 4i and negative 4i. All right, moving on. Okay, this one says 2 plus 5i is the root of the function. So then that means that our two factors are going to be x minus 2 minus 5i. And the other one's going to be x minus 2 plus 5i. Okay, so we're going to go ahead and have to multiply those two using a box. We go ahead and do that right here. Oh, that's too small. So it's going to be x, negative 2, negative 5i. X, negative 2, positive 5i. And we multiply x squared, negative 2x. Negative 2x. That would give us a positive 4. This is negative 5ix. This is that's positive 5ix, sorry. Oh. Just want to write. Okay, and then 5i times negative 2 is going to give us negative 10i. And this is going to be positive 10i. And the last box is negative 25i squared. Okay. So when we go to try to combine like terms, these two cancel out. And then so do these ones. Okay. So all we're left with here is x squared. X squared minus 4x plus 4, and then minus 25i squared. So instead of I squared, we have to write a negative 1. Negative 25 times negative 1 is going to turn into a positive 25. So to write this, it's going to be x squared minus 4x plus 25 plus 4 is 29. So we're going to go ahead and divide that into our function. Well, this is long. So here we have 3x to the 4th power minus 7x to the 3rd power plus 55x squared plus 193x. I have to split over. And then minus 348. Oh, geez. All right, so x squared minus 4x plus 29. X squared minus 4x plus 29. All right, so we're going to divide x squared plus 4x minus 29 into here. So we have an x squared and we need a 3x to the 4th power. So we're missing a 3 and an x squared. And we multiply 3x squared times x squared is 3x to the 4th. 3x squared times 4x is going to give us negative 12x cubed. 3x squared times 29, so 3 times 29. 3 times 29 gives us 87. That's positive 87 x squared. So we go and subtract, that turns minus, plus, minus, and then these two cancel. This is going to give us 5x cubed. These two are going to give us negative 32x squared. And we drop the 193x. All right, and we start all over. We have an x squared and we need a 5x to the 3rd power. So for sure we're missing a 5 and we're missing an x. So we're going to multiply 5x times x squared is 5x cubed. 5x times negative 4x is negative 20x squared. 5x times 29, 5 times 29 gives us 145. And then we go in and subtract. Oh, it doesn't make an x. Okay, so then we subtract minus plus minus. So 5x cubed minus 5x cubed will cancel. Negative 32 plus 20 gives us negative 12x squared. 193 minus 145 is going to give us 48 and a positive 48x. And then we drop the negative 348. All right, last time, if I can get this to make an 8. Okay. We have a negative 12x squared and we need we have an x squared and we need a negative 12x squared. So on here it's going to be negative 12. And we're going to multiply negative 12 times x squared is negative 12x squared. Negative 12 times negative 4 is going to give me a positive 48x. And then last, negative 12 times 29 is going to give me 348, positive 348. So now, dang it, we're ready to subtract. So all of these signs will change. Everything ends up canceling out. So when it all cancels out, that means we did everything correctly. Oh, this is a lot of work for one problem, but we're almost done. So after we go ahead and multiply, we divide, and then now we have quadratic formula. So A, B, and C. So we're going to do negative B. So negative 5 plus or minus the square root of B squared. So 5 squared minus 4 times 3 times negative 12. All of this is going to be over 2 times A. So 2 times 3. All right, so this is going to give us negative 5 plus or minus the square root of, I'm going to go ahead and do 4 times 3 times negative 12. That gives us 144. So 25 plus 144 gives us 169. Over 2 times 3 is 6. Negative 5 plus or minus the square root of 169 is 13 over 6. We split it into 2 different equations. So it's going to be negative 5 plus 13 over 6. And here is going to be negative 5 minus 13 over 6. So negative 5 minus 13 is going to be negative 18. We divide it by 6, and that gives us negative 3. So there's one. The other one is going to be negative 5 plus 13 over 6. Negative 5 plus 13 is 8, and 8 over 6 is going to reduce to 4 over 3. Plus the other 2 given zeros, which were complex numbers, which is why this problem was so crazy. But one was 2 plus 5i, and the other one's going to be 2 minus 5i. Okay, the next one. The last two. Write the simplest polynomial function with zeros, 2i, negative 2i, and 6. Okay. Now this one, unlike the assignment, it doesn't have to pass through a certain point, so we don't have to find a. All we have to do is multiply all of them. So if 2i is a 0, x minus 2i is a factor. Negative 2i is a 0, then x plus 2i is a factor, and this last one is x minus 6. Now we're going to multiply these two, and it's going to give us x squared plus 4. Then we're going to take that and multiply it times x minus 6. Now just for space and time purposes, I'm going to go ahead and use FOIL. So FOIL means that you multiply the first one. So x times x squared gives us x cubed. Oh my God, I'm going crazy. This isn't writing. X cubed. And then first, so then for FOIL, it's first, outer, inner, last. So then the outside ones. So outside are x squared and -6 are -6x squared. And then the inside ones, these two are the inside ones. 4 times x is 4x, so plus 4x. And last is the last one. So 4 and -6 give us -24. None of these are like terms, so that would be your final answer. So let's try this again. It'll be x minus 3i is a factor, x plus 3i is a factor, and then x plus 4 is another factor. So I'm going to multiply these two. That's going to give me x squared plus 9, x plus 4, and I'm going to use FOIL again. So we're going to multiply the first ones. X squared and x cubed, x is x cubed. Outside, so x and 4 is going to give me 4x squared. And then FOI, I is next. So I is going to be the inner ones, which is 9 and x. So it'll be plus 9x. And then the last one. So the last ones are 9 times 4 is 36. And that would be our answer. And like I said, it doesn't tell you for it to pass through a certain point. So after you go ahead and multiply them, we're done there. If you guys have any more questions, you guys can come see me during study skills or tomorrow morning I will be in my classroom.